Hi, today we're going to be graphing quadratics. Now, quadratics are a very important part of algebra. They show up a whole ton, and they're widely used in a variety of contexts, from engineering to your math class. And as part of your math class, you are often going to be asked to graph quadratics. And that may seem a little tricky at first because you might have only been using them algebraically. So here we're going to go over how to graph quadratics in a pretty easy, efficient way, which we're going to expand on in a couple more videos. So let's start with keeping things very, very simple. Right? So when we're graphing, we use the coordinate plane. And we number that coordinate plane along the x and the y axis. Right? So if we were graphing, say, a linear equation, we write it as y equals, let's say, 2x minus 1, where this number 2 here is the slope, and this number negative 1 here is the y-intercept, which would mean that we are at that this line touches or crosses the y-axis at negative 1, right? So, and if we were to graph this, it'd be up 2 over 1, so it'd be something like the line for this equation would look something like this. And we can kind of follow the same similar process that we use to graph linear equations when we're graphing quadratic equations. We can still use that y-intercept trick, and we can still always plug in points, right? And find values that we can use to plot the general trajectory of the graph, right? So if you want to find out, okay, so we're at negative 1, well, we're at 0 here. How do we move to negative? What happens when we go to 1? We can plug in 1 and find that at x equals 1, y will equal 2 minus 1, or 1. And then we can plot that point and start connecting the points. Now let's actually work with quadratics. And when we're doing so, just to keep things simple, to avoid things getting really confusing, we're going to be using the simplest quadratic, the simplest possible quadratic, and that is y equals x squared, right? So the quadratic we're working with is x squared, and that y equals just means, okay, so we're going to have a value x, and then we're going to have a value y that we plot, but that y is just going to be x squared. So we're plotting x on the x-axis and x squared on the y-axis. And let's actually start by doing that. And to figure out how this graph is going to look, we're going to plug in some points, right? So I'm going to make myself an x, y table, right? So at x equals 0, 0 squared is 0, so my y is going to be 0. At x is 1, I'm going to have 1 squared, which is 1. So my y is going to be 1. At x equals 2, I'm going to have 2 squared. So my y is going to be 4. At x equals 3, I'm going to have 3 squared, so my y is going to be 9. Okay, so I can start plotting these points and connecting them to get a general idea of what this is going to look like. So 0, 0, 1, 1, 2, 4, and 3, 9. And start to see, hey, this is looking like a curve. But we've only done the right side, so to speak, of this graph, right? What happens when we plug in negative numbers? What if I plug in negative 1? Well, negative 1 times negative 1 is positive 1, so my y is going to be positive 1. I plug in negative 2. I'm going to get negative 2 times negative 2, so I'm going to have positive 4. And we can start plotting them. And we notice, hey, we're getting a similar pattern as we did on points at the right. So we can speculate, and we can confirm this, right? If I plug in negative 3, I'm going to get 9, right? So we have the same style of curve on both sides. So I'm going to add a little arrow because this goes on for infinity. And this is my graph of y equals x squared. And we call this style of graph, where it's almost like a bowl, right? Like this with my hands. We call this style of graph a parabola. And the graph of a quadratic, right, with, a polynomial with degree 2, its graph will always be some form of a parabola, right? This kind of bowl shape, but not necessarily in the exact same position and shape that we saw. For example, if we had something like y equals negative x squared, how's that going to change? So I'll have my 1, 2, 3, my... Right? So I'll use my table of values, just to make things nice and easy. I plug in 0, 0 times 0, that's 0. Plug in 1, 1 times 1, that's 1, times this negative sign, right? It means that my y is actually going to be negative 1. I plug in 2, 2 times 2 is 4. That negative sign means it's actually negative 4. And I'm going to do my negatives too, just for good measure. So I'm going to do negative 1. Negative 1 times negative 1 is 1. With a negative sign, that's actually negative 1. At negative 2, I get negative 4. So if we go about graphing this, we actually find a pretty interesting relationship. And again, I'm just writing my points approximately. We get the same style of curve, except this time, instead of it being like an upward-facing bowl, it's downward-facing. We've kind of flipped it. It's something like this. This is still a parabola. This is still a parabola. It's just that the position of it's changed. We've kind of taken it how it originally was, and then flipped it. We flipped it over the x-axis. A more formal term would be saying we've reflected it over the x-axis to get this. And so we can say, okay, well, if I have a quadratic and there's a negative sign out in front, when I graph it, I know my parabola is not going to be like this. It's going to be like this. But what if we have other terms, right? What if we were to make this a little more complex and have something like, okay, negative x squared plus 5. What's that going to be? Well, as always, I'm going to turn to my table of values and try to figure out points on the graph of this equation. So 0. 0 squared is 0. Negative 0 plus 5, that's 5. 1 squared, that's actually negative 1 plus 5, or 4. 2 squared is 4. That's negative sign, so I have negative 4 plus 5. That's 1. Of course, I'll do my negatives, and I get the same resulting end value, because when I square a negative, I get a positive, so it'd be the same as when I was dealing with my positives. So we actually see, if we were to graph this, let's say I'll just graph on top of this. That's 5, 1, 4, negative 1, 4, 2, 1. I actually get the exact same quadratic, just moved up 5 units, right? If I were to take this graph right here, and bump it up, let's say 5 units, I would get this graph. And why is that? Well, that's because we have this little 5 here that says, okay, your y-intercept is 5 now. Before, with just y equals negative x squared, it was 0. But by bumping it up 5, we shifted up 5, right? And if this was, say, a negative 5, we'd have the inverse result. We'd shift our graph down 5 units on the y-axis. So when we have this value, this constant we call it, at the end here, it influences how our graph's going to look like. So this can be especially helpful when you're graphing pretty simple quadratics, because you can say, okay, I know what x squared looks like. That looks like a parabola. Okay, I have a negative. That means it's going to be an inverse. oh, and I know I'm down 5, so it's going to be that shifted down 5 units on the y-axis. But what if you have something more complicated, that we can't just use our standard x squared formula for? We know it's going to be a parabola, but we don't know its exact values. We don't know what style it's going to look like. Let's say we have something like y equals x squared minus 5x plus 4. All right, and we're asked to graph that. Well, that looks pretty tricky. We've got this middle term, this negative 5x here, that really messes up our plans. If this was just x squared plus 4, okay, well, we know what x squared is, and we know what 4 is, so we'd be pretty set when it comes to graphing it, right? We just know, okay, this is our standard parabola, except it's shifted up 4 units on the y-axis. But this negative 5x, it messes up our plans. But I guess I'm going to try plugging in points. I'm going to try plugging in points and seeing if I can get a pattern that'll make it easier for me to solve these types of problems in the future. If I can see some sort of relationship with this style that I can then apply to other problems. So I'm going to get out my coordinate plane. Say 1, 2, 3, 4, -1, -2, -3, -4. All right. So I'll start by finding random points and trying to get a general style of them. But I'll have a strategy. I don't want super high points, like, oh, if I have like a point that's 1,000 -16, I'm not going to want that. That's not useful. I want points that are close to 0 on the y-axis. And I want to get a general sense of the general pattern of the curve. So I'm going to start simply with just 0. Right? Just 0. So 0 squared minus 5 times 0 plus 4. That's just 4. That's just 4. So I know my y-intercept is 4 right here. So then I say, okay, this is pretty high. And I know that this x squared is positive, so it's not like I'm going down. So this is either part of something going up this way or something going up this way. But I don't know which. So I'm going to plug points in on either side to figure out where is this upwards curve coming from. Is it coming from this side or is it coming from this side? So I'm going to plug in 1 first and see what I get. So that's 1 squared minus 5 times 1 plus 4. That's 1 minus 5 plus 4. That's 5 minus 5, or 0. So at 1, or at 0. So 1, 0. So it seems pretty clear that if we were to connect these points, we're going down, we're coming up this way, right? Coming up this way. And if I plug in -1, just to be sure, I get 1 plus 5 plus 4. That's 6 plus 4, that's 10. 10 is all the way up here. We're not coming up to 4. No, we're going up from 4. So we know, hey, the main curves, the main two bowls or the curves of our graph are occurring on this side, right? Because I'm curving up to this point. So now I say, okay, well, I have one curve generally established, right? I have one curve that goes like this upwards, with 4 as an example. Actually, that's really messy. I'm going to try to clean that up. But we know we have one curve out of the way. We know a parabola has 2 curves. So let's try to find that other curve. Well, we're at 0 at 1. how far negative do we go? Let's try 2. Let's see what I'm at 2. So 2 squared is 4 minus 5 times 2 is 10 plus 4, that's 8 minus 10, or at negative 2. So at 2, I'm at negative 2. So I'm looking at something like this. Okay. Let's just try 4. Just let's see how far negative we keep going. So 4 squared is 16 minus 5 times 4 is 20 plus 4. That's actually 20 minus 20, or 0. So I'm positive. So at some point here, between this interval, I become positive. That's interesting. We're going to keep that in the back of our minds for now. Once we've got the full graph, we'll come in and we'll see if we can do something with that. But we're going to keep going and seeing if the curve behaves like we expect. So let's say, what happens when x equals 5? 5 squared is 25 minus 25, actually, plus 4. That's just 4, right? So we're back up right where we started. So we know that this is a positive curve. And then we've graphed this thing. Our parabola is finished. And we say, okay, that's pretty interesting. Unlike the x squareds and the negative x squareds, where they touched the x-axis at 0, right? This graph, it touches the x-axis, then becomes negative, then becomes positive, then touches the x-axis again, and then goes up back into a nice curve. And we say that's interesting. And I just happened to notice that the places that it touches the x-axis at 1 and 4 are the solutions to this equation if you set this equal to 0. And I'll show you what you mean. If we were to factor this equation, right? And this is quadratic, so we factor quadratics by looking at this term, this 4, and saying, okay, what are the factors of 4? When I add them together, I get negative 5. I know they have to be negative numbers because they add to a negative number, but they multiply to a positive number. So I'm thinking x minus 1 and x minus 4, right? I'm thinking negative 1 and negative 4. So these are what I have. And that equals 0. And that makes sense, right? In this graph, right? At these two points, they equal 0. But how do I get these 2 points from this equation? Right? Well, if these two x values multiply to be 0, that means either one of them has to be 0, because 0 times anything is 0, right? So x minus 1 could be 0. X minus 4 could be 0 as well, right? So if we simplify these equations, we just get x equals 1 and x equals 4. And sure enough, those are the exact places that graph becomes 0. So a nice, quick, and easy way to graph this, we can say, is, oh, if I have a complicated quadratic like that, what I can do is I can factor it, find its zeros, and then I get the general idea of the curve, and then I can go ahead and plot other points to get the general idea of the curve as well. Now, there's one other topic that I'd like to introduce for now. Just introduce, not go real deep into it. And that's called the vertex. Every parabola, which is of course the graph of a quadratic, has a vertex, or a point at which it comes to a cusp, so to speak, right? Where this curve meets at a single point. In this case, it's right here. What is that point? In this case, it's the lowest possible point. Well, a vertex is always going to be exactly halfway between your two 0 values, or solutions, or roots, as you may call them, right? So it's going to be exactly halfway between 1 and 4. And that makes sense if you think about it, right? We have to, at here, we start by going negative, and at here we come up and we're going positive. So at some point, we have to go from negative to positive. And since the graphs of quadratics are pretty symmetrical, right? Just like if in the graph of x squared, what we had on one side, we had the exact same thing on the other side. Right? Quadratics are symmetrical like that. That means that change from negative to positive is going to have to occur halfway between the two zeros, the two solutions. So the vertex is always going to be halfway between there. And so that means that you can graph any quadratic as long as you know the roots. Because you can find the roots, find the point halfway between them, plug that in to get the y value. Then you have this point, this point, this point, boom, boom, boom. I can graph my quadratic. That's the basics. We're going to go more into how we can deal with vertexes in the next video. I hope you enjoyed, and I hope you have a great day.